Okay, welcome to electrochemistry, which is going to take us back to some things that we learned previously. Because we're doing electrochemistry, we're looking at oxidation reduction reactions. Because we've got to look at the interchange of chemical energy, which is just the balanced equation, and electrical. We're going to look at two different types, spontaneous reactions, which we will see later in these notes that those are called galvanic cells, or use electrical current, and those are electrolytic cells. So, to review oxidation reduction, electrons are transferred. So when we were learning about our types of reactions, single replacement, something like this, not balanced, transfers electrons. Combination, which combination is also called synthesis, involves the transfer of electrons. Decomposition, which would be the reverse of synthesis. Combustion, which remember combustion was anything plus O2. Double replacement is not redox, because remember double replacement was neutralization and the precipitation. Okay? So oxidation reduction involves the transfer of electrons, but sometimes you can't see that in the reaction. So oxidation, loss of electrons, gain of oxygen, increase in oxidation number. Also, loss of hydrogen. Reduction is exactly the opposite. So gain of hydrogen. This is how we would look at it in organic systems. But here we're going to be tracking what loses or gains electrons. And one way we're going to do that is by looking at oxidation numbers. Okay. When we have a reaction, and this reaction is the same thing as this, because this compound is formed from those ions. And you need to look at that way so that you can break it up into the half reactions. So our definition of oxidation was loss of electrons. Electrons are a product, so they're being lost. Reduction is a gain of electrons. Electrons are a reactant, so they're being gained. And if we look at oxidation numbers, oxidation number of an uncombined element is 0. So 0 to 2 is an increase. And then 0 to negative 2 is a decrease.